Good day, dear participants. I hope everyone is doing great. I am welcoming you in the fourth module of the Delphi method lecture series. Today, we will be discussing analyzing the data collected in a Delphi study. So far, we know what is Delphi study and its background, its conducting processes, and data collection techniques. In today's lecture, we will be concentrating on data analysis and further rounding in Delphi studies. Before detailing those techniques, let's recap the module 3 a bit, where we learned different data collecting methods in Delphi studies. Typical data collecting methods in Delphi studies. We went through 4 data collecting methods in the last lecture, namely brainstorming, literature study, interviews, and questionnaires. Through brainstorming, researchers can identify the important investigating factors, where literature study provides a summarized version of the relevant factors covered in a scientific publication. Interview sessions are conducted for collecting data in a real-world setting, where questionnaires are used for evaluating the inspecting factors and collecting additional data related to the inquiry. Please consult module 3 for detailed discussion on these data collecting methods. So now let's proceed further with the actual session for today, knowing the different data analysis techniques in typical Delphi studies. In addition to gaining acceptable results for the existing study, understanding the analysis not only help us to decide the next Delphi rounds, but also tells us where to stop in the research that we are currently conducting. The data analysis process in Delphi studies can be divided into 4 phases, including initial evaluation, iterative process, gaining consensus, and final evaluation. The overall process is summarized in the demonstrated figure. The first phase of the analysis, the initial evaluation, consists of developing an exhaustive list of inspecting factors and placing these items on a questionnaire to assess their degree of importance to the success of the research inquiry. The second phase, the iterative process, involves reassessing the items by asking the panel of experts to reevaluate the degree of importance of each item and eliminating those items from the list that deemed unimportant. By comparing against a median or a percentage threshold, each item can be placed on a subsequent survey for further clarification. The third phase, the consensus, is the process of determining if consensus is achieved or not. Consensus is usually determined by either achieving 70% of agreement or disagreement of an item under inspection, or if no significant changes to the median score are achieved in 2 consecutive rounds. In phase 4, the researchers groups all the new but important proposals from the panel into common themes and report those items and their containment. The process becomes iterative from here and begins the stage from phase 2 through 4 until consensus is achieved. The number of rounds varies by the study type and the amount of disagreement that may arise. Although not listed as a phase in data analysis, understanding the stability of response is important because it can indicate whether consensus was present throughout and whether it was developed or changed between rounds. Since we do the initial evaluation in inspecting factors before placing them into the questionnaire and covered in module 3, I am not discussing it today. I will be detailing the process of calculating the consensus and stability in this lecture that will cover rest of the phases mentioned here. So the consensus. How consensus is defined in Delphi studies depends on the question being asked and the implication of research. Consensus can either be used to determine if the agreement exists or as a stopping guideline of Delphi rounds. Consensus has been conceptualized differently across Delphi studies, and no agreement exists on which this is the best criteria to use. It has been determined through the agreement of judgment, subjective level of central tendency, and by confirming the stability of responses. Consensus within rounds typically measures the agreement of the individual participants with the statement, which then provides group opinion and the extent to which participants agree with each other. Here in the next slide, I will be exemplifying the 7 main methods used to achieve consensus. For percent agreement, it typically requires more than 80% agreement between panel members to accept or deny an inquiring factors, whereas median ranking requires indicators above a predefined threshold and a high level of agreement among panel members. Setting up the threshold both for percentage and median depends on research type and or researchers' preferences or understanding. Interquartile range less than 3 on a 9-point scale indicates decrease in variance, which means rating with disagreement. Some formal measures are also available to denote agreement, such as Kappa statistics, Kronberg's alpha, intra-class correlation coefficient, and Kendall's tau. Rand Corporation has its own criteria for achieving consensus. To gain the agreement or median, a 9-member panel should be using a 9-point Likert scale, where no more than 2 members rate the indication outside the 3-point region. Studies are also in support of considering proportion and central tendency within a range for gaining the necessary consensus. In the former case, the proportion of experts who rate the indicator within the highest region of the scale must be greater than a predefined threshold. For example, 75% or more of the experts giving the indicator a score of 7, 8, or 9. While central tendency is considered in the latter case, selection is based only on a median score greater than a predefined threshold. For example, indicators having a median score of 7 or more are selected. However, based on the research inquiry or its type, we are allowed to combine different methods or choose dedicated ones. In general, percent agreement and median score methods are widely used for achieving consensus in Delphi studies. I will be detailing on the percent agreement issue in the next. Now we will be checking how a threshold or cutoff point can be identified for determining the consensus for the inspecting issues. In most Delphi studies, consensus means that there is a general agreement about a statement. It is assumed that a consensus has been achieved when a certain percentage of votes falls within a predefined or prescribed range or past a threshold. The prescribed range can be determined by average point of majority of opinions. We will be calling it APMO afterwards. That produces a cutoff rate for determining whether consensus has been achieved. Peter Kapoor established this formula in his PhD thesis in 1987. To calculate APMO, we first add the total majority agreement and the total majority disagreement, and then divide the summation by the total opinions expressed. The majority for an inquiring issue is defined by identifying the achieving percentage of more than 50. In order to reach consensus, an inquiring issue must achieve the percentage for agree, disagree, or disagree that is higher than the APMO cutoff rate. The issues that do not reach consensus in the first round proceed to the second round for further inspection. Let's get a case from the literature as an example to learn calculating APMO and deciding consensus. Whether a statement has reached consensus or not depends on the APMO cutoff point. In order to calculate this rate, the numbers of majority agreements and disagreements have to be calculated first. This is achieved by inspecting the participants' comments, agree, disagree, and unable to comment in percentage per statement. A comment has reached majority in the case when its percentage is larger than 50. After totaling the majority agreements and disagreements, their sum is divided by the total number of opinion expressed. The APMO cutoff point in the first round Delphi in this study is 0.697. That is resulted by dividing the total number of 135 majority agreements and 24 majority disagreement by the 228 opinions expressed. To get the percentile threshold, we need to multiply the cutoff point by 100. The 11 counted majorities are emphasized in the table. However, the detailed calculation is demonstrated here. 9 issues during the first round reached a percentage of agreement that is higher than 69.7% and thus reached consensus. Rest of the issues will be proceeding to the next round for further inspection. Let's check how stable the responses are. So the stability of response. The stability of response measures the reliability of results and refer to the level of agreement between rounds. It should not be confused with the consensus, although it has been suggested that stability of response is more reliable indicator of consensus. It measures the internal reliability and not the consensus. It is necessary to ensure results are stable and reliable because consensus is meaningless if group stability has not been obtained. Responses are considered stable when there is no significant change in 2 consecutive rounds. It helps deciding next Delphi rounds or stopping further round. Before elaborating further rounding issues, let's continue learning a bit more about stability testing techniques. So here are the things that I was discussing. Now, the stability of response testing techniques. Pearson's chi-squared has been used to test for stability, but there has been advised against using it in Delphi studies because it determines the independence of the rounds from responses found in them and not the stability of response between rounds. Kappa statistics have been advocated with the high or increased kappa values that demonstrate stability of individual views within the group. However, kappa is a measure for nominal scale agreement and assumes that rating has no natural ordering. Tests that are suitable for dealing with ordinal datasets prefer the Wilcoxon matched pair signed rank test to test the stability of response. This technique works with paired data of the same group of individuals in a before and after situation. The stability of response could also be reported by providing data on the median and the interquartile range across rounds through graphical representations of means and standard deviations or with interclass correlation coefficient. To examine the stability in different rounds of Delphi study, coefficient of variance technique can also be employed. It is particularly useful when you want to compare results from 2 different surveys or tests that have different measures and values. Along with Kendall's concordance coefficient or Kendall's tau, I found the coefficient of variance effective on deciding the next Delphi rounds in my study. So I recommend using this for the similar purpose. Let's check how can the coefficient of variance be calculated in the next. The coefficient of variance calculation will be denoted as CV afterwards. As previously mentioned, the CV is particularly useful when you want to compare results from 2 different surveys or tests that have different measures or values. It is a measure of relative variability. It is the ratio of the standard deviation to the mean. However, multiplying the coefficient by 100 is an optional step to get a percentage as opposed to the decimal. For example, if we compare the results from the demonstrated data set collected in a real setting, we can say that by having CV of 54%, factor 6 has more variation in response, and by having CV of 18%, factor 3 has the least variation relative to their means. This indicates that participants are already agreeing with the importance of factor 3, but not confident about factor 6. This must be affecting the consensus achievement for factor 6. If you concentrate on the participants' rating in this example, you can easily reveal the reality. By using built-in formulae in MS Excel, you can easily calculate mean and standard deviation and proceed further to set your own formula to calculate the coefficient of variance or CV. However, according to the literature, the level of stability achievement is defined by having the CV value greater than 0 and less than or equal to 0.5. Now let's check how can we use this in identifying subsequent rounds and finding stopping criteria for further rounding. So determining further Delphi rounds. First, subsequent rounding. Both quantitative, for example, distribution statistics, rating and ranking, and qualitative, for example, identifying new themes or factors, analysis are performed on the returned questionnaires to prepare a feedback report for the panel. It also assists the moderator or the researcher in preparing materials for the next round. Questionnaire items for the following rounds might become more specific or precise, focusing on the areas where consensus has not yet been achieved. Now, stop rounding. Although 3 or 4 rounds are typically used, the researchers should stop the rounds when researchers should stop rounding when the criteria for consensus are achieved, or when results become repetitive, or when an impasse is reached. Impasse is reached. Sorry. We must understand that panel members can lose interest if too many rounds are demanded, or if the study extends for a prolonged period of time. The CV and Kendall's tau can help us deciding whether to go further rounding or should stop in the existing round. Let's do it with an example in real setting. But before proceeding further with the example, let me discuss the notion of Kendall's tau, because I will be using it for detecting further survey rounds. Kendall tau is used in statistics for identifying degree of agreement upon and inspecting issue among panel members. To represent agreement and disagreement, the tau returns the value of 0 to 1, where 0 expresses a perfect disagreement and 1 constitutes definite agreement. However, since it is difficult or sometimes impractical to achieve ideal agreement or understanding, 0.7 is considered as a higher level of general agreement in Delphi studies. We can easily calculate Kendall's tau by using SPSS software. And from the previous discussion, we already know the agreement threshold for the coefficient of variance that ranges from 0 to 0.5, right? However, the moderator researcher still have the flexibility to go for further rounding if the CV value is much closer to 0.5. For better results, my suggestion is to keep the CV value less than 0.4 if possible. We can also concentrate on having a small CV difference between 2 subsequent rounds to stop further rounding. And as I placed here, my preference is CV difference less than 0.25. Let's see the example now. Here comes another example of a Delphi study of 2 rounds from a real setting. you are getting a full view of the analysis here, finding consensus, calculating CVs and CV differences, and Kendall's tau. Now discuss why the researcher goes from 1 to round 2 and stop afterward. If you inspect the data in round 1, you can see that its Kendall's tau is 0.26, which is very low comparing to the considered value of 0.7. Additionally, round 1 has more than 50% of CV values that cross 0.4 threshold. So the researcher found it logical to roll the second round of the survey and share the result from the first round with the panelists. In round 2, most factors achieved a reasonable degree of agreement, which is less than 0.3 of CV values or a little bit more. This is very good improvement in stability in response, I would say. The Kendall's tau also received a good increase in its value from 0.26 to 0.41, although it is still a bit lower than the considered value. To determine whether further rounds should be conducted, the researchers additionally compared the CV values from both rounds and identify a marginal CV difference, and that is around 0.25 maximum for a case only. Others are less than that. So the researchers decided to stop conducting further rounds of the Delphi study because this study achieved the stability in general agreement by gaining a good decrease in CV values, a good increase in Kendall's tau, and less CV difference. The findings were then reported to a targeted or appropriate channels. Now let's summarize the entire Delphi procedure with a flowchart in the next. This is the flowchart for a Delphi procedure. Please understand that this is not the flowchart, but a flowchart. It is not necessary that our procedure would exactly be the same. You may have your own flowchart or procedure. However, they covered all the main steps necessary for conducting a Delphi study. You can refer to this while designing your own framework. And this is it from me for module 4. So by now we have not only collected data, but also analyzed them. Please be informed that finding consensus and stability is not the only outcome from Delphi data. You can use them in many other purposes, such as studying correlation between answers, how different groups react to different inspecting factors, their motivations, the challenges to conduct such a study, to identify new research areas or strengths, to discover new focus group, and so on. Please note that all the references are attached as a separate file in the course content. In the next module, we will be discussing reporting the results and understanding their validity, reliability, and strength or appropriateness. We will also be checking the limitations of Delphi studies in the next lecture. So thank you very much for your kind attention. I am looking forward to seeing you in the next lecture.